Hello and welcome. Today we're going to have a look at how edge braking in SolidCAM can really help you finish off parts perfectly. As we can see, I've got a 5-axis part that I've done all the machining on, but there's one thing left to do. That's making sure we have no sharp edges in the part. I've started off by using an edge braking toolpath, and let's see what we get from the default settings in the toolpath. Open up the SolidCAM simulator and expanded it so we can see it a little better. We can see it plays straight away, and SolidCAM has found all the sharp edges within our part and applied a toolpath to try and break them. You can see it turns the tool in all 5 axes because the machine we're using is capable of this, whilst maintaining it doesn't collide with the stock or the fixture. As we can see, it's gone round, picked out all the edges and done a great job of something straight away. But there is more to this toolpath if we want to define something more specific. For instance, we may not want to address the top of the radii that it's currently getting, or we may have not wanted to go as deep on the toolpath, or we might even not want to go in all 5 axes of the machine's rotation. All this can be done, and let's explore how this is possible from this starting point. Moving out of the SolidCAM simulator and turning on the toolpath, we can see it's done a great job of edge braking so far, but the vertical section at the bottom of the part may want getting rid of. This is a really easy thing to do. In automatic edge detection, we can limit by height, and simply from changing that from 27 to 25, we can get rid of those. If we wanted to go further, obviously we can raise that further, so to -20 takes the bottom edge out completely, and you can see all of those top surfaces remain to break. Let's move on from this and see how we can optimise this further. We may want to manually edge detect rather than use the automatic function. As you can see, I'm just going to collect a series of edges on this one side as a representation for when we go and alter any other parameters. Obviously I can always come back and edit this at any time, or switch back to automatic. From this again, we'll save and calculate the toolpath, and we'll see how it drastically changes from having lots of edges to just purely the edges that we'd picked previously. A really good way to optimise what you want to do. We can also change the levels of retraction, and also change the width of the chamfer that we want to do, in this case going from 0.2 to 0.5 mm. Again, let's have a look at that under simulation and see what's changed and how it works now. As the simulator is loaded up and we expand it again, what we should expect is all the edges we've selected to be broken, and this to be done with minimal fuss and using all the rotary axes available. And as we look through the simulation, that's exactly what we've got, with no errors being reported. Moving on from this, let's have a look if your machine doesn't have 5 axes, what can we do? The first thing I've done is select 3 axis, and what this does, it just purely take out any rotary or tilt that is in the toolpath currently, but will still break all the edges that are achievable. From here, let's expand the simulator and play this through again to see how our change to move to 3 axis has affected our toolpath. As we can see, the tool is still clearing up the chamfer that we want to the thickness that we require. However, it's having to do a few more movements to make sure that this is constant. This is because we've taken out the limitation of it cannot move in a rotary axis or a tilt axis. From this again, we could go and check the simulation and the part to make sure that everything is what we want it to be. The next option we'll look at in output format is 4+1 auto tilt. In here we've assigned the rotary axis to be the x-axis to prioritise that, but if there's ever a need to tilt to make sure that we cut correctly, this will add it as needed. As we can see from the simulation, this will be no problem for it whatsoever. So to recap, what we've seen is one of the rotary axes is being kept static, and then the second will rotate slightly, so you can see that in the X direction, if that's what we've picked. Another option that's similar but with slightly different results is 5-axis minimal tilting. The difference with this one is we don't have to pick a preferential axis because it can use all 5 at the same time. It will still try it and minimise the tilt used though, so you only should be moving absolutely when it's necessary. Again, upon reviewing these toolpaths, we can see the 4+1 auto tilt and the 5-axis minimal tilting can give similar results, but this depends on your machine and your part, and sometimes one may just edge out slightly, giving you a slightly better finish. The main thing is there's multiple options for you to choose from, as and when you need them. Finally, let's move back to full 5-axis motion, like we had originally. Let's review that again, just to see where the differences are. As the tool starts to move, we can see, in this instance, all axes that can rotate move at the same time and are constantly shifting to make sure that our ball nose tool is making a constant edge break across each edge and across corners as well, giving you a great result. Another option that's really worth mentioning is link. In here we can choose to return to the clearance area or go to a clearance blend spline. With a blend spline going straight from one toolpath to the next in a safe manner, potentially saving you extra time in your deburring operation. Finally, let's talk about tooling. So far we've only used a ball nose mill, but you can use an end mill or a chamfer mill as well. In this instance, I've got a 4mm chamfer mill, and let's look at how the toolpath changes slightly as we deal with this different changing tool. As you can see, it's still got all the edges, and let's look at the simulator to see how this has changed. Reviewing the toolpath created, we can see the tilt and the rotary of the tool is quite different. This all takes into account the differences we have in the tool geometry, moving from a ball nose cutter to a chamfer mill. What it will mean though is we still get the chamfer that we require upon our part to make sure we've machined it absolutely as we expect it. So I hope this whistle stop tour has given you everything you need to get started straight away with edge breaking in SolidCAM. And thanks for watching.